Hi guys, this is Peter Moore from the TaskCluster team. Today we are going to run through the second tutorial in the series on the generic worker. In this tutorial we are going to see how to create a new Windows AMI with all the tools installed that we would like. Then we're going to create a worker type based on this AMI, and finally we will create a task which runs on this new worker type. So the purpose of this tutorial is to see how to set up a new Windows environment with all the tools installed on it that you need for integrating with TaskCluster for running jobs on that Windows environment. So let's start by going straight to AWS to create a new Windows environment. So here I'm going to log into the Mozilla TaskCluster Amazon account. Use my temporary credentials. Okay, in here we have EC2, where the EC2 servers live, and we're going to go straight to launch instance. So here I'm going to pick one of the standard AMIs that Amazon offers. Please note you can start with any AMI you wish. The reason I'm starting with one of the standard AMIs offered by Amazon is to demonstrate that there's nothing TaskCluster specific built into this AMI that I'm starting from. So I'm going to pick the Windows 2008 R2 base, and this is our starting point. The instance size I will set to C3X large. And here in the instance details I can leave this all as standard. However, under advanced details I have the possibility of specifying some user data. When creating Windows AMIs, if you specify PowerShell code for your user data, then this PowerShell code will be executed when the instance launches. We're going to use this trick to install the generic worker on this base image. As you saw, this base image was just the standard Microsoft Windows 2008 Server R2 version from Amazon. But when we log into it, we should see that the generic worker is installed because of the PowerShell script we're about to specify. This PowerShell script currently lives under the generic worker GitHub project. Here we have a file called Notes Windows, and in here, right at the bottom, we have user data. You need to specify the PowerShell tag and the close PowerShell tag at the bottom in order for this trick to work. So I've copied that into my clipboard, and now I'm going to paste that. While the instance is launching, I will go through that script and explain what it is doing. I'm not going to add any storage, but I am going to tag the instance, and I'm going to call this generic worker demo. The security group we can leave. Here we have RDP enabled. This means that when the instance launches, we can RDP in. The security groups here that we specify are only for this instance that we are creating now, in order to capture the virtual machine to use inside an AMI. Later on, when the provisioner spawns instances, it will not use these security groups. It will use the security groups that are specified in the worker type. So don't worry that anything you do here will have impact on the final implementation with the task cluster. This is purely just so that we can RDP into the machine for the purposes of setting it up the first time. Okay, that looks all good to me. I'm going to leave everything as it is. And now I'm going to specify a key pair. In the demo that we are going to do today, we're going to create an AMI, and then later on the provisioner will spawn instances based on this AMI. With Windows, the password that we set for this AMI when we create it is going to be the same as the password for every instance that the provisioner creates. We specify a key pair one time now that we decrypt later. And this is the key that I'm specifying. So I just want to call this out right now. When you get to this stage and you select a key pair, whichever key pair you use, it doesn't really matter, as long as you have the private key, that will be used to decrypt the administrator password. And once you get that password, you need to keep that safe, because every instance that the provisioner spawns will have the same password. This is slightly different to the Linux setup, where you can manage authentication using the key pair. In Windows, you're using the administrator password. Okay, let's launch the instance. So while this is launching, let's have a look through this PowerShell script that we specified in the user data. The first thing I want to mention is this PowerShell script actually does more than we technically need, because I created this PowerShell script in order to set up a worker type that could build Go code. The worker type that we're creating now won't need to build Go code, but I've left those parts in for simplicity. However, they're technically not needed. So this PowerShell script starts by defining a function, and this function simply downloads a zip file from a URL, and then it extracts it. Here you see client.download file, downloads it, and then for each file in the zip, here you can see that it gets extracted on the file system. So the first step we have here is install Go. Like I said, this step technically isn't needed, but I will explain what it's doing anyway. Here we create a directory, c:\go path. We call the expand zip file function that I just showed you up here. We download Go 1.4.2 as a zip file from this URL. We save it to this location, c:\go 142 Windows AMD 64.zip, and then we extract it to this location. Since it contains its own top level folder in the zip file, this won't dirty up the root directory, but it will put it all under the Go 142 subfolder. Okay, the next step we do is install PS Tools. This is a requirement for the generic worker at the moment. PS Tools is used by the generic worker as a mechanism for spawning a sub-process under a different user account than the generic worker is running under. Let me explain this. The generic worker runs under whichever user account we install it with. However, every task that it executes, it will execute under a unique user specifically created for that task. So the generic worker will start up, it will create a new Windows user. It will create a home directory for that user, and when it picks its first task from the queue and executes it, it will execute it as that user from the home directory of the user. When that task is completed, the home directory will be deleted, the registry entries will be deleted, any processes will be stopped, and then the generic worker will create the next user for the next task. The reason we do this is to create a clean environment for each task to run under. Since we don't reuse the Windows user, it means that the home directory is always clean and the environment should be clean. The user that is created is not an administrator. It only has write access to its home directory, and the only registry entries that it can change are those that are under HKey current user. This means it shouldn't be possible for any task to leave the system in a bad state, because the task can only affect the user that it is running under, which exists only for the lifetime of that task. Okay, and that's why we use PS Tools, because PS Tools is a utility that allows you to run a process as a different user to the process that you're running under. So here we download it from this URL and we extract it to c:/PS Tools. NSSM comes next. This is a utility that we use for installing the generic worker as a Windows service. Again, we download a zip file and we extract it. Then we install Git. Git is useful to have on the system. It's technically not needed unless your task requires Git. Most of them probably do. Use either Git or HG. Here, Git is a self-installing executable. So rather than expanding a zip file or extracting a zip file, we download the exe and run it directly, specifying some arguments, and we wait for that process to finish using $p.hasExited. Here we set some environment variables. The first one is the Go root, which is used for Go. Like I said, you don't need this if you're not compiling Go code on the worker. Similarly, the third one, the Go path, we also do not need unless you want to compile Go code. The second one, here we set the path and we add Git to the path. Now the last three steps pertain entirely to the generic worker installation. We create a directory to stick the generic worker in, c:/generic worker. We download the generic worker from the releases page of the generic worker project. If I scroll to the top, go back to generic worker and click on releases, here you see this is where we publish all of the binary releases of the generic worker. Currently the latest is 1.0.11. These releases are created automatically every time we push a tag to TaskCluster, to the generic worker project. We have a Travis job which will create the binaries and publish them back to GitHub. Since the generic worker is written in Go and Go generates native executables, you do not need anything else on the system other than the executable itself, because it is self-contained. So here you see the generic worker for Windows is a .exe file. You download that exe and you have everything you need. Okay, now I'm going to step back. Go back to the notes that we were just looking at. I think we were towards the end. So this is where we downloaded the exe. Then we set the environment variable debug to star. This is a mechanism to enable the generic worker installation to generate logs. And here we call the generic worker exe and we specify an argument install --config and a config file to create. And here we redirect the standard error and the standard out to log files. This works because we've set the debug environment variable here. Without this, there would be no logging. Okay, we wait for the installation to complete, which we do with this $p.hasExited. And when this PowerShell script completes, the generic worker should be installed as a Windows service. Please note the Windows service is not started, so the Windows service will not be running after running this PowerShell script. That is intended, and I will explain that in a second when we're on the machine. My guess is this instance has launched now. I can't remember what I called it. Generic worker demo maybe. generic worker demo. So we see that the instance state here is running. So I will now get the Windows password. Here I'm required to select my certificate, which is the one I selected earlier when creating the instance. This allows me to decrypt the password. The point here is this password is everything you need for accessing the machine, and not only this machine, any instances that will be created by the provisioner later based on this image. So it's very important we keep a safe copy of this password. So let's log into the machine. You will remember we enabled RDP in the security groups. So we should be able to RDP in. The password I've copied into my clipboard. Username is administrator. PC name. I am going to use the public IP, which is this. And I will start full screen mode. So after a warning, we should be in. And we're now logging in for the first time. So some operations, such as opening the server manager, will be a little bit slower because it's the first time they've run. So let's do that straight away. Here I'm clicking on the server manager because I want to check that the generic worker has been installed as a Windows service. So under configuration, we see services. Like I say, it shouldn't be started, but it should be set to automatically start up on reboot. We haven't rebooted since installing it, and that's why it hasn't started up. Here we go, generic worker. Here we have a description. We see it hasn't started, and the startup type is automatic. So this is exactly what we wanted. We can see it's running under the generic worker local account, which has also been created as part of the installation procedure. Okay, at this point, you have a fresh Windows image with your generic worker installed. Typically now you would install all of your tool chains that you need for building your jobs. So for example, Visual Studio, GCC compiler, maybe some test frameworks that you might need. For the purposes of this demo, I'm going to create a batch file which outputs text just for the purposes of demonstrating how it works. So here, let's not forget the magic echo word. I have a batch script that writes I am a batch script to test.txt in the current directory. I'm going to save that. I'll put it under C. I'm going to call it test.bat. I'm now going to test that it's working. There we see it, test.bat, and no test.txt file. Now I run test.bat and have a look again, and now we see the test.txt file. I'm going to delete it. and we see it's gone again. So at this point, the test.txt file does not exist anywhere on the system. I'm highlighting this because when we create a job, our job is going to run test.bat, and the test.txt file we're going to publish as an artifact. So I want to highlight that at the moment the test.txt file does not exist on the file system to demonstrate that it only gets generated by running the test.bat file, which is available from the context of the task that we create. So I'm going to close my windows, and I have now done everything I need to do in order to create my image. So we're going to come out of the Windows environment, and from the EC2 console I'm going to create an AMI, which I do by going to Image, Create Image. The image name I'm going to call Generic Worker Test. Description, demo test for creating a new Windows generic worker environment. This tick box is very important. When we create this image, Amazon will shut down the instance and then create the image unless we tick this box. But we actually want the image, the environment, to be shut down before the image is created. And the reason for this is when the instance when an instance spawned from that image starts, it will boot up, and then we know that the generic worker will start up. At the moment, the generic worker is not running. By not ticking this box, we guarantee that first of all we have a clean image that's created because the system isn't running when we take the snapshot, and secondly, when any instance starts up based on this image, we know that the generic worker will start up. When the generic worker first starts up, it reads the user data, which is provided by the provisioner, and that user data contains all of the configuration it needs in order to talk to the queue, the TaskCluster queue. The provisioner creates temporary credentials, which it provides access to via the user data. So the generic worker is designed that when it starts up, it queries the user data to get that information back. And that's why until now we haven't started it up, because we only want it to start up once that data is available, and that will only be available when the instance is spawned by the provisioner, since the provisioner will be creating that data for it. Okay, that's a lot of detail, probably not all so interesting. The long story short, don't tick this box. Okay, so that image is being created, and you see it has provided us with an AMI ID, AMI A1E629CA. So while we wait for that to start up, we should now create a worker type that uses it. In order to do that, I'm going to go to tools.taskcluster.net and then go to the provisioner. Please note the provisioner here comes under the domain tools.taskcluster.net. There was a different provisioner under a different address. This is the new provisioner. Make sure you're using this one. So at the bottom, by the way, I have logged in using my credentials here, my Mozilla account with a persona login. If you have any access problems reaching this page, then send a message in the IRC channel, irc.mozilla.org, in the #TaskCluster channel. So here I'm going to create a worker type. As I scroll down, the name I am going to give it is Generic Worker Test, to be consistent with what I've called the AMI. Max capacity I'm going to set to 1 for now. This is the maximum number of jobs that should be able to be run in parallel. For example, if we said we always want to be able to run 100 tasks in parallel, we would set this to 100. This is different to the number of tasks that can be run in parallel on an individual worker. That we can specify in the instance type data. The generic worker, however, currently only supports running one job at a time, one task at a time. Therefore, capacity utility should be 1, and max capacity here will actually be the number of machines that get created, because each machine can only run one job at once. Okay, the next step is to fill in the region. We created this excuse me, in North Virginia, which is US East. So I'm going to set this to US East 1 rather. So I'm going to set this to US East 1. Then we should specify the AMI ID, which we have got here. I beg your pardon, we don't have it there because we are actually going to the AMIs to see .248. So it must be this one. Yes, I believe it's this generic worker test, July the 7th, 2015, 248. It's 252 now, so it must be this one. Okay. So let's grab the name of that. And put that in the image ID. Okay, scopes. Here you can limit the scopes available. We don't want to limit this in this test because this is beyond the scope of this particular demo. But in principle, if you want to restrict the scopes that are available for this instance, for the worker running on this instance, you can specify tighter scopes here. The launch specification, it's also useful to specify a security group here. This isn't technically needed, but is useful in case there is a problem. So when the provisioner spawns an instance, it will apply these security groups to that instance. And sometimes, if there are problems and we can't see what the problems are, we might want to RDP into the instance. So I'm going to put it in the security group RDP only. And this means that for any instance that the provisioner creates, we can RDP in. Obviously, we need to keep tight hold of the password that we were given, because all of the instances spawned will have the same password. So I think that's everything that we need for the worker type. We have the scope set, we have the security group set. We don't need any user data. Region is changed to US East 1. We specified the AMI ID to use. We're specifying that we want X-large, C3 X-large instances to be created. One last thing that we can do for the purpose of this demo is to increase the minimum bid price. This just guarantees that we will quickly get an instance spawned. At the end of the demo, I will delete this worker type so that we're not wasting money. With a higher bid, it just means that the spot instance should be fulfilled more quickly. Okay, I'm going to create this worker type. At the moment, we haven't created any tasks in the task creator, so there will be no tasks pending for this worker type. That means that the provisioner will not try to provision any instances yet. So it doesn't matter that this AMI might not be available yet. I suspect the AMI is available. Yes, the AMI is available. Okay, so the last thing to do then is now to create a task which uses this new worker type. Since the AMI is available, the provisioner will be able to provision a new instance when the task is submitted. So again, let's go to tools.taskcluster.net, and this time we go to the task creator. The provisioner ID is correct. It's the standard provisioner, AWS Provisioner v1. Actually, let me reset this. The worker type, we're going to specify the new worker type that we've just set up, which I think I called generic worker test. Generic worker test. Created and deadline are auto-filled to sensible values. Payload, we don't need an image, that's for the Docker worker. We don't use that in the generic worker. For command, we specify one string per command. And just for fun, I'm going to run set, which shows me my environment variables. Then I'm going to call the batch script that we created, and that should generate the test.txt file in the current directory, which will be the home directory of the user. Max runtime 10 minutes, we can leave that. But let's specify an artifact. Artifacts is a list, so we have square brackets. Each entry in the list is an object, so we have curly brackets. We have to specify the type, which is file, which is the only type that we support currently in the generic worker. The path, this is the relative path from the home directory. So it is simply test.txt, since the task is executed from the home directory of the user. And finally, expires. Today is July the 7th, 2015. So I will set the expiry to July the 8th, midday. In GMT or UTC. So here we have artifacts covered. We're going to run set to look at our environment variables. Then we are going to run the bat file that we've created, which exists only on this worker type. Then we're going to publish an artifact, which is a file, which is the test.txt file created by test.bat. And we're going to set it to expire tomorrow at midday in UTC. This relates to how long the artifact will be published on S3 and will live on S3. After tomorrow midday, it won't be available on S3 anymore. Okay, we can fill in some metadata just to be complete. Name, generic worker test, description, we'll put run c:" test.bat. The owner we'll make as me, pmore@mozilla.com, and the source is the task creator because we were running this from the task creator. So fingers crossed, if we haven't made any mistakes, or if I haven't made any mistakes when I run this, it should be set to pending. The provisioner should update, and it should detect that we have a pending task for generic worker test. I'm going to hit refresh. Generic worker test, one pending task. So soon we should have an orange bar with a number 1 in it to demonstrate that there is a spot request that has been raised. And if I go to the EC2 management console and go to instances, no, spot requests, and do a search for the AMI, we can see that there is an open spot request. So the provisioner has correctly requested an instance. If we go back here and hit refresh, no doubt we will see it. So I would expect to see an orange with a number 1 to show that a spot request has been made. I think this must be a bug in the user interface of the provisioner, because when I go to Amazon I can see that there is an open spot request. It's correctly been made at $0.5, so 50 cents. And I'm going to refresh now. Okay, we now see that the spot instance is active. It may take a short while for that environment to boot up and configure itself, but we can watch the task inspector, and when the instance is booted up, then we should see the state change from pending to running. Okay, we see the task has started running now. We go to the Run 0 tab. We see we have a green state completed. We have our log files, and the test.txt file has been published. And if we check the contents, I am a batch script, which is exactly what our tool that we created, the batch script that we created, output. So I think this hopefully has demonstrated all of the steps. If we go to the all commands, we see here's the output of the set command where we see all our environment. Here we see we executed the c:\test.bat. Here you can see what it executed, and that's precisely what we put in the text file, in the batch file. So the last thing I will do to avoid that we waste any more money is I will delete the generic worker test worker type, and the way I do that is I click on it, I select edit definition, and then I click remove worker type. That's now removed the worker type, and I will double check that the instance will get terminated. And here we see that the instance is indeed shutting down, ready for termination. It's important to do this so that we don't have workers costing money running in the wild. Okay, and there we see it's terminated. So thank you very much for joining me. I hope this was informative. Please feel free to post questions. Visit irc.mozilla.org and the # TaskCluster channel.